Hello, I'm Shirai Smith and I'm going to be presenting my dissertation research exploring the effects of post-activation potentiation on active range of motion through strength-focused isometric contraction of the hip flexors. The aim of this study was to bridge a gap in current research on post-activation potentiation, or PAP, and explore new methods of training active range of motion. The research explored the potential use of post-activation potentiation to improve active range of motion. 5 female participants currently training in contemporary dance at Trinity Laban were tested using a modified straight leg raise test to measure their angle of active hip flexion before and after a 10-second isometric maximal voluntary contraction of the hip flexors against a fixed surface. Research in dance science suggests that dancers are not being trained sufficiently for the demands of performance, specifically with regards to active range of motion. Often passive range of motion is trained in traditional dance classes, and supplementary training is needed but avoided due to a stigma. There is a lot of research available on post-activation potentiation, specifically on improving strength, power, and force output. Despite research being conducted solely for the purpose of identifying the optimum conditions for PAP, the ideal contraction duration and rest time between activation and testing is still undetermined. There is also no published research specific to dance or for the improvement of active range of motion through strength. All participants completed a 5-minute pulse raiser on the stationary bike, activating the hip flexors, and then followed the warm-up video that is available on this channel, which consisted of mobility and dynamic stretches which were designed for the intervention and testing. The dancers completed a passive standing straight leg raise test to ensure they met the inclusion criteria of a higher passive than active angle of flexion. A pre-intervention active straight leg test was then conducted against a plain backing using a 5K HD digital camera and adjustable tripod, which was set to the hip height of each dancer from 4 meters away. The participants held on to a ballet bar for balance assistance and were instructed to look forward. For a valid test, both legs had to be turned out and straight. The kicking leg also had to have a pointed foot. No restrictions were put in place to limit pelvic tilt, but participants were instructed to maintain a neutral pelvis as much as possible. These parameters were decided on to make the test as dance-specific as possible and to make the findings more applicable. The standing straight leg raise kicks were recorded for 2D motion caption analysis. 3 attempts were done on each leg for the average scores to be statistically analysed. The intervention consisted of a 10-second isometric maximal voluntary contraction of the hip flexors against a 6-foot Olympic barbell which was set to the hip height of participants and weighted down to be a non-moving object. The dancer's leg was flexed to 90 degrees at the hip and knee. To ensure the contraction was maximal, they were asked to rate their exertion on the Borg scale. If they reported a perceived exertion of less than 10, the intervention had to be repeated. Using electromyography sensors to identify maximum output would have been more accurate, but due to the limitations of this project, the Borg scale was selected. There is a great deal of uncertainty with regard to the best rest time between intervention and testing and contraction times. After accumulating research suggestions, a rest period of 4 minutes was selected. After the 4 minutes rest, the standing SLR test was repeated and dancers then began to cool down, which was a 3-minute walk on the treadmill and a pre-recorded stretching mobility exercise video that was created to support the dancers going out of this intervention and to avoid any negative effects from the intervention and testing. This video again is available in the channel. This slide shows images of testing. The image on the left is the camera on the adjustable tripod at 4 meters away from the backing and ballet bar where the dancers stood for testing. On the right is an example of the angle measurement of an individual participant during a passive straight leg raise test. On the left of this slide is an image showing the intervention with a participant holding onto the squat rack for stability and pressing up against the fixed bar with knee and hip at 90 degrees of flexion. On the right is an example of the Borg scale that was used for participants to rate their perceived exertion to ensure that maximal contraction was continued for 10 seconds. Data analysis showed an average improvement of 5.77 degrees on the left leg and 7.84 degrees on the right. The difference that PAP caused was deemed significant on the right leg, but insignificant on the left. One participant's left leg did not meet the inclusion criteria, meaning only 4 sets of data were included. Another participant's score was unchanged by PAP on the left leg, having a big impact on the average due to minimal data. This may have been an anomaly, as it was the only before and after measurement that did not increase, but it cannot be confirmed due to a lack of data. This graph shows the average pre- and post-intervention hip flexion scores of both legs of all of the data collected. On the left of the graph, the left leg pre- and post-intervention scores are shown. On the right side of the graph, the right leg intervention scores are shown. Both intervention scores are considerably higher than the pre-intervention scores. However, only the right leg had a significant difference according to data. For a more conclusive answer to the effects of strength-focused PAP on active range of motion, further research would be needed. Additional datasets and better informed methods with regards to contraction time and rest would provide a better understanding of post-activation potentiation potential. At this time, application of PAP is greatly limited by a lack of understanding and the short duration of improvement. The use of PAP could be used to improve active range of motion in screening tests for auditions, as the duration of tests is shorter than the duration of improvement, which, according to other research, is potentially up to 20 minutes or could be considerably less. It could also be used to improve active range of motion in small sections of performance. But dancers wishing to utilize PAP need an understanding of the duration limitations and activation requirements. This information is still greatly questionable, and application could be further limited by the unpredictability of performance. Unfortunately, due to inconclusive results, the hypothesis for this research was unable to be accepted. That does not mean to say that the results did not show that post-activation potentiation could improve active range of motion. More research is needed to fully understand and apply post-activation potentiation, both in respect to active range of motion and PAP in general. The results from this study could be used in conjunction with other research to continue to explore the potential of post-activation potentiation. Thank you for listening to my presentation, and I hope you have found this information interesting.